Fourth video on the unit looks at geometric series. So remember the difference between a sequence and a series. A sequence is just a list, a string of numbers in a pattern, and a series is the sum. So what we're going to do today is add all the terms of a geometric sequence together. And again, here's a quick formula or form of what we're going to do. We're simply going to add up all the terms. Remember, geometric sequence is found differently than in arithmetic, but obviously the value of the first term is just the first term, and then we find the common ratio and we multiply the first term by the common ratio and get the second term, and we multiply that one again by r and get the third term until finally we get the very last term. And what this simple formula generates with a bit of manipulation are these two formulas right here. And here are the two formulas we're going to use. And again, as I've said all along, I highly recommend you write these on a separate summary formula sheet. And in this form of figuring out the sum of the series, this is when you know the first term, you know the number of terms and the first term. So if we know the number of terms, we can use this formula. And in our second formula, if we know the last term without necessarily the number of terms, we're going to use that one. So here's these two ideas right here. And again, notice that T1 is in both of them and R is in both of them. But here are the two forms. And really what it becomes is practice and algebra practice and recognizing and getting comfortable. So hopefully we see that in both cases r cannot be 1. If r is 1, it's very boring first of all, but then these formulas won't work because the bottom would be 1 minus r, 1 minus 1, which was 0, and that's the problem. So let's look at a few examples, and again, it's really meant for us to determine which one of those two formulas we're going to use. So in the first one, again, what I want you to recognize is you know n, even though it's not explicitly said, you know n, it's 7. So we're going to use the first formula. Similarly over here, we know n, it's 9. We're going to use the first formula. And in C down here, well, we want to figure out S of n, but we don't know how many there are, but we do know the last term, so we're going to use the second version of the formula. So these are these things we want to think about when we're doing them. And of course, R and T of 1 is in our formulas, and T of 1 is given all the time. R may or not be. So R is 1/2. And we could figure out that by dividing the next term by the one in front of it, which is fraction arithmetic, which is 3 over 6, which is 1 over 2. And then we're going to use our formula. S of 7 is equal to 1/3 times 1 minus 1 over 2 to the power 7, 1 minus 1/2. And we're going to figure out the top and the bottom. Now again, my rule of thumb is if you have fractions, the answer is in fractions. If you have decimals in the question, then decimals are acceptable. So we're going to go ahead and solve this. And the top is going to be 1 minus 1 over 128. And that equals 1/3 over 127. Over 128 divided by 1/2. And again, I'm running out of space, so I'm going to jump to the final answer, which is 127 over 192. So make sure you can go from there to there. Okay, and the second one, same idea as we talked about before. We're going to use our first form of the formula, and we have to figure out what r is. And in this case, r is equal to -2. So notice that the sign is changing, negative, positive, negative, positive, negative. So we're going to have a negative in our common ratio, and 4.2 divided by 2.1 is 2. So we're going to go ahead and figure out what S of 9 is. It is T1 times 1 minus negative 2 to the power 9, and the brackets are really important, over 1 minus negative 2. And 1 minus negative 2 is positive 3, so we get 2.1 times 1 minus negative 2 to the 9 is 512. So 1 minus negative 512. So that turns out to be 2.1 times 1 plus. So here's our negative, minus a negative is a plus. So we get 513 all over 3. And this is where we could get out our calculator and answer 359.1. So we still use the same formula, but it's the idea of decimals and fractions and what's expected. And finally, this last one, well, again, we have to use the second formula because we don't have the number of terms, but we do have the last term. So this one, S of n, we don't know what it is right now, is equal to T1 negative 6 minus R. Well, again, R, how do I go from negative 6 to 24 and 24 to negative 96? Well, we multiply by negative 4. So R is equal to negative 4. We're going to have negative 4 times 98304 all over 1 minus negative 4. And again, the brackets are really important. And when we do our calculation on top, we get negative 6 plus 393216 all over 5. And when you push those buttons on your calculator, 78642. So again, we have to be able to identify which formula to use and when. Okay, let's do a few more. So again, in this one, I'm giving you the information. So T1 is 2700, R is 10, and N is 8. And again, this is all about thinking about choosing the formula. And again, the key idea here is we have N. So given we have N, we want our first formula. So S of N, we don't have to figure them all out. We don't have to add them all up. We're going to have 2,700 times 1 minus 10 to the power 8 all over 1 minus 10. And this is going to be a really big number. Now, the top, like 10 to the power 8 is 1 with 8 zeros. So that's going to be 999, that's a whole bunch of 9s. So again, as long as, when you're using your calculator, as long as you put brackets and then you do the whole top and you close the brackets and you divide and you brackets and you do the whole bottom, your calculator could tell you the answer, or you could break it up into two pieces. I know the bottom is negative 9. But when you punch this into our calculator, we're going to get 2.9999. A lot of those times 10 to the power 10, a really big number. And again, really big numbers are why we might not want to figure out the string. So if the first term is 2,700, the next term is going to be 27,000. The next term is going to be 270,000, etc., etc., etc. Those are big numbers, and we have to figure out a lot of them. Well, here's a neat little example where we're given the arithmetic formula, or sorry, the geometric formula for the term, for this sequence, to figure out the value of a sequence, and we want to write S of n. So again, the problem here is, well, the problem seems to be, well, we have no information. S of n means obviously we don't have the nth term. We don't know what it is. And we don't have the last term, which is actual T of n as a number. But if we figure out what the sequence is using this bit of information right here, then we can actually collect some data, which is not explicitly given, but then we can generate the sequence. So in this one right here, if you knew what these letters stood, if you knew what the numbers stood for, if you knew what the 2 meant, and if you knew what the 3 meant, you could really simply make a sequence. So again, if we go back to our formula, the 2 represents T1. So in this one right here, T1 is equal to 2 because we have our T of n is equal to T1 times R to the n minus 1. And given that we know R is 3, then we know we're going to multiply every subsequent term, and it's going to go dot, 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 dot. So right there, I have enough information. I have enough information to fill in, use one of my formulas and figure out what it is. I have R, and I can go ahead and generate my S of n. So S of n is equal to T1 times 1 minus 3 to the n over 1 minus 3. And this turns into 2 times 1 minus 3 to the n over negative 2. And the 2's cancel out. And I have negative 1 minus 3 to the n. And if I distribute the negative, I have 3 to the n minus 1. So here's our formula. And if you want to make sure it's true, well, T1 plus T2 is equal to 2 plus 6, which is equal to 8. So the sum of the first 2 terms is 8. And if we wanted to use this formula to figure out S of 2, 9 minus 1 is 8. So our formula is good. And then finally, one last one. Again, a real-life application. And it's all about you reading the question and understanding what the sentence is saying. So the first one's giving you the story, and the second sentence says, the doctor administrates 200 milligrams on day 1. So there's our T1. Our T1 is 200 milligrams, and the dosage is reduced. The dosage is reduced by 50% on each successive day. Well, that's R. So again, what are we doing? We're cutting it in half. We're cutting it in half, or we're multiplying by 1/2. So R is equal to 0.5, N is 7, and we're finally asked what is the total amount of medication prescribed. So we're asking for S7. So again, we have N. We want our first formula. S of 7 is equal to 1 minus 0.5. T1 is 200 times 1 minus 0.5 to the power 7. And again, get in the habit of putting the base in brackets when you use your calculator. And when you push those buttons on your calculator, 396.875 milligrams. So one of the big ideas in this section is deciding which formula you want to use.